Today we are going to talk about the highway geometric design, and to give you a brief about the highway geometric design, this is actually part and parcel of the overall highway alignment or highway improvement project. So whenever we talk about the highway project or highway improvement project, the first thing, like any other project, it comes from the planning, and that is the basic and the first step of that. In the planning, we look into the demand and from there we try to find out whether there is a need to do certain improvement. So once we do the planning and once we know that there is a certain improvement needed or new highway is needed, then we go for the design. And to be honest, design engineers are the primary or the main project manager in every stage till it's being constructed. So far, what I have seen, project manager, the geometric designer provides a support role during the planning stage, and so that they know what is the improvement they need and how it can be designed, whether the design is going to be feasible or not. Once they know, once that is being fully proved that okay, the improvement is needed, everything is taken care of, the next phase goes to the design. And in the design, the design engineer, they are again the lead, take the lead role and do the design according to the requirement. And once a project is designed, it goes for a construction. And during construction also, sometime it may so happen that some improvements are needed, some adjustments are needed, and when these are needed, of course the design engineer plays their role and they provide the technical details in there. And once the project is constructed, then it goes for operation and maintenance. Probably this is the time when design engineer's role is not, they don't have a lot of role, but if there is some improvement needed, again the design engineer comes into play. So this is actually the vital part of a highway project, and this is what we are going to discuss today. I hope I hope all of you are on board. So with that, basically I'm going to start my highway geometric design course today. So the overall the course is divided. If you look into the content, we are going to talk about the highway development in India. And once we look into the highway development, any development, we need to know the kind of history behind it, how it has been organized and how things are moving in at present. So that is what we are going to discuss in the highway development in India. The second part is we'll be looking into the functional classification. So anytime we are looking into some development, we need to look into what is the priority of that development, how we are going to do this, how the funds should be dispersed and so forth. So that's why we need to have a priority set for the different roles. So we need to know how we can classify the role. I'll come into more details about this particular aspect when I'm going to cover this part in the later part of today. Then comes the highway project. So what is the highway project? How it evolves from the planning to design and we make it ready for the construction. We'll be briefly discussing that in the highway project. So once we discuss all these things, we'll get into more about the design aspect. So the primary stage about the design aspect is the site distance in highway project. What is site distance, how it is being used, I'll be discussing that. So these are the primary things which I'm going to discuss today. These are the basic things of the design. Once we know the basic things about this design, we'll move on to the overall design of a highway. And this overall design involves horizontal alignment and the vertical profile. And this is what I'll start in the next lecture, which is going to be tomorrow. So I hope all of you are on board and you are following me. And do you have any questions so far? So that was about our course content, and the expectation from this course content, basically at the end of the course you will know about highway design, the details about the design process, and you'll have a basic understanding of the design, how it is being designed in the field and how it is being executed. What are the nitty-gritty details of that? you will know about those. So today we are going to start with the introduction of highway development in India. To look into that highway development in India, we need to look into the timeline major development which happened over the period. So over the period, the major highway development plan, if you look into the first time when it tried to organize the overall highway improvement, was done in 1928 by Jayakar committee, and this committee was the first formal organized way of looking into the overall aspect, and they proposed various things, and that shaped our improvement or the development plan in India. And if you look into based on their recommendation, we had started various things like this fund CRF, and then the IRC, CRRI, and so forth. And this is what we'll be discussing again once we get into that. And they also recommend that every few years we need to revisit our development and look into the kind of development we had in the past 20 years or 10 years and so forth, and what should be our future direction. So this is why it came to this Nagpur Road Congress. It is a 20-year plan which started in 1943, and they had a vision for next 20 years, which is till 1963. And this is the first time they had many new changes, the road categories and so forth. I'll be discussing this again in details. They set some goal, and based on that goal, basically they looked into the development of the roadway system. Once that is achieved, the next 20-year plan came up in 1961. They achieved it 2 years early. That is why the next 20-year plan didn't start at 1962, but it started at 1961. So this was the Bombay Road Congress, and this is for plan from 1961 to 1981. Again, there were certain earmark or certain improvement strategies which were being considered, and certain targets were set for this, and based on that improvement, the roadway improvement, the new road construction happened. We'll be again discussing this thing. Once it ended in 1981, the next 20-year plan is the Lucknow Road Congress, and this is for 1981 to 2001. So with that came the new era, millennium era. So in there you will see that we had one vision for 2021. This is another 20-year plan, and this is a 20-year road development plan. Within that, there is also a rural road development plan, which is 2025. We'll be discussing. This is how the improvement or development plan started. Then, based on this development plan, actually there are many administration and financing system which started, the offices and other things. So the first thing, as a highway project, this is a public investment, and there is a public road which users are going to use. So we need money. So the first thing about the money, how to get that money. So this is why they started this Central Road Fund, which started in 1927, and it was actually suggested by Jayakar committee. And according to that, once it started, basically we formalized like what is how the money is going to come in and how it is going to be used, and how it is going to be taken forward. The next, another plan or another suggestion which came from Jayakar committee is the Indian Roads Congress, a organization through which all these the development can be synchronized and looked into, and they get a same overall platform to look into this development. To execute this development and to look after from the government side, MORTH came up, which is Ministry of Road Transport and Highways. And also to look into the development or the research part, CRRI was formed in 1950, which is Central Road Research Institute. They looked into various development, the research part component of it, and provided the guidance for the development. And to execute it, in 1956, National Highway Act was passed. What is the National Highway Act? How does it help? We'll be discussing that. The other board which came up was the Highway Research Board. or this also is for the research, and this is part of IRC. This is an initiative from the IRC and it is within the IRC. This was formed in 1973. Then came the organization which actually execute it in the field, which is National Highway Authorities of India, and this started in 1998. They are primarily responsible for the national highway. So looking into the planning, the Jayakar committee, which met in 1928. This was the first committee, as I had mentioned, for to examine the road condition and the development and to provide a preliminary direction towards this. And this was started post World War, when they felt that the fund needs to be organized, how the fund should come, how the development should occur, and this is why the committee was formed. They proposed this Central Road Fund. So there is some error here. In the previous slide you will see the Central Road Fund was suggested in 1927, but it is in 1929 when it was executed. So the Central Road Fund, this is how to tax and how to use that money in the development of the highways. Then they also suggested about the Indian Roads Congress, which was formed in 1931. It's a semi-government body for the professional highway engineers who are in that field, and this is still exists, and they have a wide presence all over the country. They also have a conference every year where they meet and discuss about the various issues and how to improve the roadway. They also suggested a research organization, and based on this the Central Road Research Institute, which is CRRI, was formed in 1950. As per Jayakar Committee's suggestion, the various 20-year road plans came up, which is Nagpur Road Congress from 1943 to 1963, which met in 1943 and come up with the first 20-year plan. And what was their main motive at that time? Basically, people started constructing road, and there was fund which we need to use to restore it and keep it in a condition in which the vehicles can fly. So basically the road, of course, anything other like anything, it start deteriorating. The road started deteriorating and the road condition become poor after World War II. So they need to find out how we can use the money which is coming from Central Road Fund through taxation, how we can use this money effectively and efficiently to develop the roadway project. This is where the necessity came to find out the category of roadway. So they proposed the road classification such as national highway, state highway, district road, village road, so forth. So why did they do this classification? To prioritize the funding. So, and how to prioritize this funding? There are again category of this roadway, like national highway means it's of national importance. So the roadway which are connecting the mainly the state capitals are national highways, and within the state which are connecting the district headquarters probably are the state highways. So these are of kind of national importance, and based on that the funding could be dispersed and the road could be improved. So this is why they came up with the classification, and which is being used so far. So if you see this classification, this road classification, these are actually for connecting the various cities within a country, and they go past by the rural areas. So this classification is called the rural road classification. We'll again come to this later. So once this, whatever the goal they set in Nagpur, so they tried to achieve that in the next 20 years. They didn't even need 20 years, within 18 years they could achieve that, and that is why it triggered the Bombay Road Congress. By this time they have already started improving the condition of the road by restoring the road and doing proper maintenance of that. However, things which came up was the quality, and this is why this is what was the main discussion point of Bombay Road Congress. So quality improvement. The other thing which needs to look into was the consideration of the semi-developed and underdeveloped agricultural areas for connectivity, because one of the thing is that we are connecting the major cities. Now how we can connect the smaller villages and other places through which we can actually prosper, the economy can evolve. So this is why the semi-developed and underdeveloped agricultural areas need to be connected. So this was again discussed and formalized in the Bombay Road Congress. Then how this is, again we have to understand, this is a planning process. So in the planning process we try to find out what should be the road length. We don't dictate here how the road, what is the alignment, how it should be designed and so forth. It is going to be the preliminary, it will come after the first planning process. So how do they decide? So they decide that what is the total road length per square kilometer or 100 square kilometer in this case. So in Nagpur earlier it was 16 kilometer per 100 square kilometer. Now it has doubled in Bombay Road Congress. So they increased it to 32 kilometer per 100 square kilometer of area. This is how the road length are going to increase. Now if we look into the construction, how we can do the construction. So we cannot construct the whole roadway at once. So there needs a stage construction. What are the specifications needed for the stage construction? That was also discussed and adopted in this Bombay Road Congress. And also this implies that lot of research needed. So that is also discussed and considered. So next comes the Lucknow Road Congress. Now in this again, once we achieve the Bombay Road Congress, the target, the Lucknow Road Congress came up, and here they started focusing the population, the village population which has villages which have population more than 500, and this is for the next 20 years. So this was the main thing which looked into. And the other thing, this is a huge industry, the highway industry. If you look into the construction and the other process, this involves a lot of people who are involved in the construction, then the transportation of the material for the construction and various other organizations. So in this process basically they look into how it can generate employment, and this is through the construction process. This was also the primary focus in this Lucknow Road Congress. The other thing in Lucknow Road Congress which happened was the further classification of the roadway. So we have many classification like national highway, state highway, and by this time the expressway concept was also coming up. Then within the district road, major district road, other district road. So how to again further classify it so that we can prioritize the fund. Again that type of classification happened, and we will be discussing that at a later stage. So once they meet this target in 2001, now it was not based on the city. Now this development plan is known as Vision 2021 Road Development Plan Vision 2021. Within that, basically they looked into what is the next 20-year development, how we can look into the maintenance of the existing asset, how we can look into the road safety. So this is why probably you will see many road safety campaigns these days, because this is the part of we are in this Road Development Plan Vision 2021. And in order to make our roads safer, definitely we have to have safety inbuilt in there. And the other thing you will be noticing while traveling on the roadway are the toll booths. So the Central Road Fund, which was based on the taxation, was not helping to generate enough revenue. And even if that revenue was generated, where to invest this? And the primary question it remains, suppose the requirement is at certain location and the money generated from all over the country, we cannot just put it in one location. So we need to look into the localized improvement and development. So in this case, the toll road concept came up. So the toll road pay as you go to be look into this process. So the agency developed the facility considering that there is a high demand, and once it is developed, they start collecting the toll from the road users, and as they collect the money from the road user, again they are going to put it into those projects. So this is how it goes in a cycle. The other plan was that the rural road. So we also need to connect the villages and the other smaller cities, So this is where the rural road came up, Vision 2025. and you may be seeing many of the developments like Pradhan Mantri Gram Sadak Yojana and other parts. And this is why the village roads are being developed these days, because now you see the target population is 100. As long as the village has a population of 100 plus, the planning process says that it needs to be connected and we need to construct roadway. So this is what the rural road vision 2025. Apart from this, we need to understand this was the highway sector or how the highway is evolving. We have to look into the other part, like whoever is using it, whoever is constructing it, maintaining it, and the other part. So one part is the users, and the users are mainly the motorized vehicles. And if you look into the motorized vehicle, a Motor Vehicle Act came up, and this act came up to regulate the traffic, road traffic, what should be the traffic law and how it should be maintained, how we can discipline the traffic, how what are the processes. So all these things came up, and the first time it came up was in 1939, and later on some improvement happened, and the latest act which is in effect is 1988. Still it is more than 3 decades old, almost 3 decades old, but it's still in exist, and there is a process in which this is further going to be enhanced. The other part is the we need to construct. So there should be law which can help in this construction process, and this is the primary importance of this construction or the roadway or the national highway. So this is why the National Highway Act came up. According to this law, basically a survey team can enter a land to carry out the survey, and this does not require a lot of permission and all those things. And if needed for the development, they can acquire land, because this is another, to develop a highway we need to have land, and that needs to be so this is why according to this act, basically the land can be acquired easily and can be used for development. Of course, the proper compensation would be given to the landowner. And this act was established in 1956, further revised in 1988, and based on this act, actually National Highways Authority of India was started and started operating from February 1995. And any project, if you see on the national highway, they are the primary authority who are actually managing those projects, whether it is toll road or not, but it is, these projects are coming from this NHAI. The other part which came up, the development, is the the Highway Research Board, which was set up in 1973 and which is part of IRC, and it is actually for the coordination and promotion of highway research among different organizations and research institutes. So Highway Research Board, they have IRC has a publication, IRC journals, and Highway Research is another journal where the researchers and practitioners they publish the research component or the new thing which come up in there, so that the information can be disseminated to the larger group of people, and which can be used for further improvement of our roadways. Some other road developments are the National Transportation Policy Committee, which was appointed in 1978, just to review all the development which are happening and looking through those the 20-year plans and so forth. And also the National Highway Development Projects, NHDP. There are NHDP 1 and NHDP 2, through which the funding is sourced for the highway development. And as I was telling you, for the rural road development, Pradhan Mantri Gram Sadak Yojana, which was launched in 2000, and it was the primary aim, the goal of this Yojana is to provide connectivity to villages by all-weather road. So many of you who are from the villages have seen that the village roads are being improved from the earthen road to a metal road, which is either a concrete or the bituminous road. So this is coming from the Pradhan Mantri Gram Sadak Yojana, or PMGSY in short. So the road development, if you look from 1950 to 2012, basically there is a drastic improvement. So the drastic improvement from the lengthwise of the total road, and also the drastic improvement in the total length of the surface road. Surface road means it's all-weather road which can be used in different conditions. So this improvement is actually the outcome of the proper planning process we have gone through the various 20 years. And if you see the trend, basically initially all various type of roadway was developing at the almost at the same pace. However, as we went beyond 1971 and or 1981, we started focusing on the rural roads, and the rural road development improved drastically, and that is the green line which you can see in this graph. So the way it started improvement. So, and then the state highway and other. So these, the other roads which is like national highway and the project roads, or basically NHDP expressways, basically they are the main corridors which carries heavy traffic or the long distance traffic. So you just need to connect at certain interval through the state highway to this higher category of roads. So this is why we have already built lot of capacity in this road. Now we are concentrating on the other roads, the village road and the state highways. Of course, we are looking into the express highways. Now coming to the state-wise, the development, you have to consider the size of the state. So that is why considering the size of the state, so Maharashtra, Uttar Pradesh, West, they have quite a high or long length of road network. So other states are also have a quite good amount of road network. The recent development, if you look into some of the projects you have probably heard about, is Golden Quadrilateral, which connects the 4 metropolitan cities, which is Delhi, Kolkata, Chennai and Mumbai. Then the other project is a north-south and east-west corridor. So the north-south, which you probably have heard about, is a road or highway which is connecting Srinagar to the Kanyakumari. So that is shown as a green line here, and the east-west corridor, which is connecting from the east Porbandar to on this side on the further northeast. So this is shown in the blue line. And as I was telling you, this development process is happening through national NHDP, National Highway Development Program, and there are 2 phases of the program, phase 1 and phase 2. Currently it is phase 2 program is going on, and these are the earmarked amount which has been set for these various phases, you can see, and accordingly these roads are being developed. The other another for the low volume roads, which is your village road and other roads, is the Bharat Nirman program. It started in 2009, and its goal is to connect the various habitats, and so far it has connected 66,000 habitats with a all-weather road, and it has constructed about 1,46,000 kilometers of new rural road network, and it has upgraded about 1,96,000, almost 2 lakh kilometers of existing road network which exists, and a huge investment has been done in this, 48,000 crore over the 4 years. So, and now it has taken over this rural road, the Vision 2025. So that concludes our development in the rural road, the road sector, how it has been evolved over the past 100 years almost. So is there any question? So can you see through like how the development plan initiated by JICA committee, and that prompted for the 20-year planning process, and this each 20-year planning process lead to various development plans like national highway development, this rural highway development, expressways development, toll roads, then the funding, NHDP, National Highway Development Project, and the other funding issues, how they are looking into, how the contracting systems are changing. So these are all part of the planning process. So if you don't have any question, next I'll move to the functional classification of roads. As I was telling you, the funding is coming, and we need to improve the road, and we need to look into the whole process of improving it. We need to prioritize. Money is there. We need to look into the roads which are in a good condition, which are of importance. We should maintain those roads in a higher level. The second level will be the other level, other roads. So based on that, we need to so that we need to classify not only for the funding but also for the design. You are not going to design a road which is next close to your house of a higher standard of a national highway where vehicles can just zip through at 100 kmph or at a higher speed. You'll be looking into various the roadway category which can actually serve at a lower speed. So this is why we also need to look into the classification. So I got a question from PCE that why there was a need for Bharat Nirman project when PMGSY was already there. So there are various agencies through which, or various vehicles I would say, through which the development process starts or happens. PMGSY, they had some goal and they were targeting the population wise. Now the Bharat Nirman project probably it came up for a reason, whatever the location what PMGSY cannot cover, the Bharat Nirman project can cover. So probably this could be one of the reasons, and it was side by side covering the other locations. And also the PMGSY may have a certain standard which some location cannot meet those standards and hence cannot be improved. One such example could be like within a village area, there could be a road which needs to connect to the marketplace and again go back to another location which is within the village itself. Now as per the criteria of PMGSY, that may not get a higher weightage because it is not connecting to the outer side, means to another village and to the higher category of road. So this particular roadway segment may not have been considered in PMGSY. So but that is also important to connect. Now in this situation, how to get this project going, how to improve this roadway. So in this case Bharat Nirman project may help because that is going to connect this marketplace with some populated area within the village. Probably that was the reason. There could be other reasons as well which I am not aware of. So now moving back to again the classification. So let's look into the classification what we have. As I told you, the first classification came up in the Nagpur plan. At that time the classification was only national highways, state highways, district roads, village roads, so forth. And as we move forward, we need further classification of those roads. So in Lucknow plan, which is in 1981, basically they came up in a 3-stage, and this is what we are talking about, the rural highways. We'll come to the urban highways and our urban roads next. So in the rural roads, these are further classified as primary roads, secondary roads and tertiary. Within primary roads, there are two classifications, which is expressways, national highways, and then comes the secondary roads. Secondary roads again comes from the state highways, major district roads. The tertiary roads are the other district roads and village roads. So coming from the funding wise, the improvement funding and who is responsible for what, the primary roads are being mainly the central government is responsible for the primary roads. So the expressways, national highways are mainly maintained or managed by the NHAI. So I got a question. Okay, so I got another question saying that Sansad Gram Sadak Yojana is a plan which is being initiated by Punjab only, or it comes under PMGSY. To be honest, I'm not quite sure about this particular plan because I haven't heard about this plan anywhere else. Probably it is in Punjab, or I'm not sure. Maybe I'll try to look into this and get back to you tomorrow. So again, coming back to the classifications, basically we can look into the classification, the rural road classification, the primary road, secondary road and tertiary road. So this primary road, this expressway, as I told you, these are actually been maintained or mainly coming from the central fund, and these are the responsibility of the central government. Whereas the secondary road, if you see the state highway, major district, again this comes from the not from the central but from the state. So within the state actually they can prioritize the fund according to the secondary road. So the secondary road, which are the state highways which are connecting the major district headquarters and the state capital are the state highways. Then the major district road, the major talukas which are connected are the major district road, and so forth. Then there are other district roads which are actually inter-district connecting two different districts, but not the major talukas or the major cities, but it's still a district road. And the village road. So the village roads now it has been taken over to some extent by the from the central through this PMGSY program, but it is actually routed through the state. So these are about the rural roads. So what happens in the city? So in the city, I mean earlier the main focus was on the rural areas. So later on we realized the cities are also expanding and we need a good road infrastructure in the city. So in the cities area or the urban area, we need a classification, and according to this, a classification came up in 1983 through IRC 86. IRC is actually a code, design code for the road development, road design, and there are various IRC Indian Road Congress codes. So the urban roads basically or the city roads, it's divided as expressway, which is of higher category, high speed and less access, means very few intersection like that. So these are the expressway. Then comes the arterial. So then comes the arterial, and then the sub-arterial. So the arterials are connecting to the expressway and the sub-arterials are connecting to the arterial. So category wise each are lower than each other. Then comes the collector street, so the local street. So if you come out in a city area, if you come out of your house, the roads which is next to your house, mainly if you are in a society or some residential area, basically you will see the local streets, and from this local street you will go to a little bit bigger street which is the collector street. And so the collector street is actually collecting all the traffic from the local street and providing circulation within a certain region. And then it goes to the sub-arterial, where you have the speed of this roadway increases, whereas the access gets reduced. And then from the sub-arterial it goes to arterial, and then from arterial you go to expressway. So if you are traveling from one end of the city to the other end, you are probably traveling in an expressway. So many times you will see the ring road, those are the to some extent expressway or part of. The other classification which is generally we don't use, but it's in common for the practitioners, is based on the usage. So if a roadway can be used all through the year, it's called all-weather road. And if the roadway is only used during the fair weather, which is in a good condition, sunny condition, so that becomes a fair weather road. So the urban road is actually a fair weather road, because in the monsoon or whenever the rain rains, you cannot use that. Whereas if you have, even if you have the roads with brick shole or concrete, these are actually all weather road to some extent. Then the other type of classification is the paved and unpaved. So fair weather roads are definitely unpaved roads, whereas all weather roads are paved. So these are the other classification just for. So the next thing we'll be looking into in the overall classification. If you look into this chart, you will see that how the functional classification of roadway has been divided. So one is, as I told you, the urban part, and another is the rural part. So the rural means non-urban, and here in the rural part you will see the national highway, state highway, district road, village roads. The district road is further divided into the urban road again is divided into expressways, arterial, sub-arterial, collector and local streets. In the rural areas also you will see the expressways, and that is also part of this. So this is the overall classification of the roadway, and as I told you, the first classification of the rural road came in Nagpur 20-year plan road congress, and the latest one which is we are using came from this Lucknow road congress, or the 1981 20-year plan. And why do we need the classification? As I was trying to explain you earlier as well, like we have fund, we need to disperse the fund, we need to manage this road, and we need to prioritize the overall funding situation and overall thing. So this is in a nutshell, to facilitate the administration of the road, assigning responsibility to the administrators for the road improvement and other things. We need this classification. Also, the design standard, as I was telling you, the design standard also needs going to be different for different category of road. So if you are not going to design the high-speed road like the road which you have next to your house, so the high-speed road should have less curve and it should be wide enough, less access so that vehicle doesn't come here and there, no parking along the road, so forth. So this is why the design standard changes, and we need to look into that. And also we need to look into the how the planners are going to look into the overall process. So this is how it is. So if there is a harmony onto that process, that is looked into. For that we need the classification. Now I got another question: which body does the major funding for PMGSY? So the PMGSY, it is coming from National Rural Road Development Agency and NRRDA, and they are actually providing the funding and the improvement for this. And now the other question I also got is, how are national highways and expressways are differentiated? So the expressway, if you look into it, is more like a freeway where access is totally controlled. Means you there won't be lot of intersection or interchanges in the rural expressways. Whereas national highways, you may see intersection and you may see more access to the national highway, and the national highway speed is like 80 kmph, whereas the expressway speed can be up to 100 kmph. And the expressway, main goal of the expressway is the higher speed, and to attain higher speed, as I told you, the access needs to be controlled, and along expressway you won't find any parking or any there shouldn't be any dhaba or those type of accesses where people can stop and do. And it is controlled through these toll booths, so people can enter from one location and exit from another location. In between there are no entry and exit to the expressway system. So this is the primary differentiation. So now we looked into the classification of the roadway. Now we'll go into the highway projects planning and execution. So when we look into the highway project, we are looking into various type of improvements and how these are being done. So let's look into the overall state planning process. The basic steps involved that we have to first of all assess the demand, and this is where the demand for road comes up, and this is the first stage of the planning process, where you do a need and purpose study and look into whether the demand is there, how it is going to be taken care of, and how it's going to be looked into. Now once you do that, you found out there is a demand, say suppose a connection between Mumbai and Ahmedabad. Now when this connection comes, what are the areas or the location which falls in between these two areas, which will be also benefited if we connect those intermediate locations. So their highway planning comes, and we need to look into the various locations what are in the process. Once we look into this location, we also need to do some preliminary and detailed survey while we look into that, for various reasons, find out what is the population who is going to, what is the demand who is going to use that population, and what is the city type, whether it is a tourist city and all those things, and how you can develop the preliminary alignment, whether the alignment is feasible or not. What are the other influencing factors in the expected economic growth in future if we connect certain intermediate cities, what is going to happen. All these things are looked into. These are part of the overall planning process. Once we come up with the basic alignment, we go into the design, and once we go into the design, this is where the two type of designs are there. One is the geometric design, and another is the pavement design. And one here in the geometric design, that is what we are going to discuss, and we'll be again look into that. And then when you are doing the design, the design involves lot of drawings and the report, how the design has been done, and how this what are the assumptions in this design and so forth. And once it is designed, it goes out for the construction. So in the construction, all the leveling, earthwork, all those things are done in the, and you will see the road being constructed in different layers. So our focus right now here is in the road design. And once it is constructed, the road is open to traffic, and beyond that point, it's operation and maintenance. So we'll go more about this basic step. At this point, we'll take a 5-minute break, and then we'll again convene in another 5 minutes to move forward from here. And in between, if you have any question, you just can pose. I will try to answer once we reconvene after 5 minutes. We got another question regarding this PMGSY and Bharat Nirman project, or this BNP. And I tried to answer that earlier as well. BNP and the Bharat Nirman project, PMGSY and BNP, basically they came for two different purposes. As I told you, PMGSY was to connect various villages from different population, and this population was started, I mean, initially the target was 500 villagers, 500 population, and then in the later stage it came to 100. So like that it was reducing, and that way started providing connectivity. Now even within that, some certain roadway may not qualify as the for this PMGSY funding, and in that situation probably probably this BNP came up to facilitate those. So another question came up is expressway is a part of urban classification. Why national highway is not a classification under urban road, because national highway also passing through different city. So the urban classification, if you look into the road overall, basically these roads are actually within the one urban setup. Means if you are looking into the Mumbai, this classification is only for the Mumbai city. If you are looking it for Ahmedabad, it is only for Ahmedabad city. So the road which is connecting from Mumbai to Ahmedabad, that road is not an urban roadway. That is actually a rural roadway, because while connecting the major two cities, it is going through many rural areas. That is why we call it a rural highway. So that is why national highway is not non-urban area. That is why it is actually part of rural classification, not part of urban classification. And expressway, if you look actually expressway, there are two types of expressway. One expressway is for the urban area, and another expressway is for the rural area. So the rural expressway have control, access control completely, whereas the urban expressway don't have that much of access control, and you will see intersections, you will see flyovers in between wherever the intersections are. The urban expressways don't have those flyovers. It will actually be totally elevated, or whenever it passes through a particular city, or there won't be any intersection where vehicle has to stop. So this is the primary difference when we are to say expressway as part of urban classification and expressway as part of rural classification. So I am trying to understand this question: necessity of national highway in non-urban area which lead to unwanted. So necessity of national highway, see, as I told you, the national highway needs to connect the major cities. So it needs to connect the major cities, and these are connected to the next level of roadways, which is like state highways. So definitely the state highways, the traffic coming from state highway needs to, if it wants to go to the another city, it needs to come to the national highway, which is if this city is in another state. So this is why we'll see intersection on the national highway. And if you eliminate the intersection and construct a interchange everywhere through proper control, then gradually it will elevate it to the expressway category. So this is the time. Now I got a question which I'm going to actually will go through the process, like how much time does it take to do preliminary survey, and how it is done. So it is part of the lecture which will come through. I cannot say for the time wise, but we'll Now another question came up is how conflict points are evaluated in national highway and expressways. The conflict points are evaluated in the same way the way you are going to evaluate in any intersection. If there is an intersection, there are conflict points which are like crossing, merging, diverging, and you have to look into all those conflict points. So this is part of more intersection design, which is not part of this course, but this is how it needs to be looked into. The other question is it possible to upgrade a state highway into national highway? If yes, what are the difficulties? State highways, yes, they can be upgraded to the national highways, but again it comes from the importance how what is the traffic it is going to carry, and the state highways so far it was within one particular state, but once we say the national highway, the national importance at least it should be connecting two neighboring states. So a state highway from one state and the state highway from another state, if they are connected and if they are upgraded and it was taken care of by the central, and they see that there is a major benefit from the economy point of view, from the two various aspects like the commercial point of view, then it will be upgraded to the national highway, and that is how it moves. And there are certain state highways which have been upgraded to the national highway as well. And I think I answered almost all the questions. Now I'll move to the remaining part of the lecture. So as I told you, the basic steps in road construction. Now in the planning process, as we have told you, the first planning process came up in the Nagpur road plan, the 20 where the roads were divided into national highway, state highway, major district road, and other district road, village road, etc. And then came the Bombay Road Plan, which is 1961 to 1981. Then came the Lucknow Road Plan, which is from 1981 to 2001, and followed by the other the Vision 2021 plan. Now, based in each of these 20-year plan, basically they set up a target in 20 years where we want to go, what is the road density we want to create, and based on that the road projects. And when we know that we need a road, the first thing we need to know the alignment. So the alignment, whenever we are talking about alignment, is actually the position or layout of the central line of a highway on the ground, and this is what is actually going to define your roadway, so which is going to connect two cities or two locations. And it is the major role which in the economic development in the region. And basically if your alignment is passing through, or your highway is passing through some location which is going to improve its economic development of that area or the commercial development, definitely it is going to improve. So it has a major role. If it was not passing, then we are going to miss that development. So this is how it goes. The alignment, if you look into, basically it is divided into two parts. One is the horizontal alignment, which is you can see on the plan profile from the top, and another is the vertical profile, which you see on, from the side. So basically the horizontal alignment it takes care of the whether it is connecting the required points or not. It also look into see the location which needs to be avoided and so forth. Whereas the vertical profile, it provides what is the earthwork it's going to take, whether there is an intersection which is connected at a proper level or not, and so forth. Whenever you are considering an alignment, basically you need to look into the that it is doable within a you have a budget constraint, and it can be constructed within that. So it becomes an optimization problem, and it itself is a research area. There are many models which have been developed, and right now actually the designers, they do based on trial and error, but there are many research optimization models which use all the cost and actually develop the alignment. Now whenever we are talking about the cost, let's look into what are the costs it involves. It involves the construction cost, maintenance cost, vehicle operation cost, accident cost, and the road user cost. So a properly designed highway will definitely not only is going to reduce the construction cost, but also reduce the maintenance cost, vehicle operation cost, and other costs. So the upfront cost which you see is the construction cost, and most of the time the decisions are made based on this upfront cost. However, there are long-term costs. Long-term cost means after it is constructed, we need to maintain, we need to the vehicle needs to operate, and within that, when it is operating, there is operation cost, and if we design or choose an poor alignment, that can lead to frequent accidents, and it can actually increase the cost, accident rate, and the cost, and the road user cost as well. Now I'll go back to and answer a few questions. One question is regarding the how toll road rates are decided on national highway and expressway. Is there any standard? Definitely there is a standard, and there are process which is actually right now not part of this course, so I'm not going to discuss into that, deviate from there. But if you search, there are certain standards how to do that. The other question is expressway has full access control, but expressway which is passing through urban area has no access control. Why it is called as expressway? As I told you, the expressway, one is for the urban setup and another is for the rural setup. So the rural setup, again, the speed is quite high, and it is for the connecting the distance. So definitely there we need to have access control. Now when the same expressway, or not the same expressway, when the expressway which is defined under the urban classification, we construct the expressway, we are just looking into better mobility and the speed through this highway, through these highways. And when we do that, we basically end up seeing few intersections, and some places, depending on the fund, when they try to construct flyovers. If we construct flyovers, at least we don't have the intersection, and we can actually manage have a better flow. So as the fund is available, they can start constructing this flyover. So not always we see the intersection on the expressway, but we will see also the flyover. It all depends on the financial status or the fund available for the construction. Okay, so the other question, again, I got a question related to the toll tax. So how toll tax for expressway and national highway are divided among state and central? Again, this is a funding question and the planning question, which is not part of the geometric design. So but in general it depends on the share of the road and some other pre-agreement which are being done between the central and the state. So there are legislation, and from there these things comes up. So that is a total different. So now I'll move again back to the lecture. Now when we talked about the alignment, as I told you that the alignment needs to connect the two cities, and it has to connect intermediate locations or avoid certain intermediate location. And once we do this, there are 4 basic things which are targeted, and these 4 basic things are that the alignment needs to be short, and if we make it short, if we make it short, basically the construction cost is going to reduce. However, it doesn't mean that the other costs are going to reduce. So we need to look into other aspect as well. So we need to have this alignment easy in a way like it is easy for the for construction, it's easy for operation, it's easy for maintenance, and so forth. So when we say easy, suppose if you are constructing a roadway through a hilly terrain, and somehow you constructed in the first go, and then there are side slopes which needs frequent maintenance. So it's not easy for the maintenance, because if you need frequent maintenance, means your maintenance cost is going to increase. If you look again, if you look construct a highway with too many curves, then it's not easy for the user. So that definitely we need to look into that. We need to look into whether it is easy, or we have to make the highway so that it is easy for the construction and maintenance, and as well as for the user. The next part is the safe. We are constructing highways, and we need to make sure that the highway is safe for the road user. So any alignment when we are choosing, we should not have a sharp curve after a long straight section. In that process, we can make sure, and this is just one example, but as we go into the design, you will see more part of those, and you will see how it is safe. Then it comes the economical. So considering all the facts, we need to make sure that it is economical in the long run as well as the short run. Short run means the construction cost is economic, and as a long run means when we are doing the maintenance and the user cost perspective, it is economic from 20 or 30 year the overall comprehensive cost of that. So in general, we need to provide a maximum utility by serving maximum population. Okay, now I think I received another question which is, or the same question, how conflict points are evaluated in national highway and expressways. So the conflict points are, again, I answered last time as well. The conflict points are evaluated the way it is evaluated at any other location. So there are primarily three types of conflict, like crossing conflict, merging conflict, and diverging conflict. And based on that, we need to look into. So expressway, we try to avoid the crossing conflicts as much as possible, and because those are the dangerous or the most dangerous situation or the dangerous conflict, and same which lies for the national highway. So if we design an intersection or the interchange in a way that we can reduce that. So now let's move into the other part, as I was saying, the influencing factor or the controlling alignment. So there are obligatory points within there, and any alignment when we are deciding, we need to look into the what are the obligatory points. Obligatory points are the points through which an alignment needs to pass through, and also the points which the alignment needs to avoid. So as I told you, if there is a city in between the two connecting cities or the metropolitan area, basically you would like to connect that. So that becomes an obligatory point, and so you can connect that intermediate city for the development. And if you, and also you want to, if your alignment is passing through a river, you want to make sure that it is passing through a river where the width is quite low. So that becomes your obligatory point. Or wherever there is less meandering, or the 20 year down the line there is no meandering within the river, you will try to pass your bridge at that location. So that becomes your obligatory point. And also there are certain obligatory points which you don't want to pass through, the alignment should not pass through. Example is forest area with the preserved forest, so you don't want to affect the natural resources, so you would be like to avoid the alignment going through that. The other influencing factor is the traffic. So if you know that certain amount of traffic is going to come from certain location, and that needs a higher and going to travel to a city in another state or another place, so you would like your alignment to pass through that area, and you want to bring this traffic safely into this. And also the traffic is going to tell you how many lanes you need on that particular highway. The other influencing factor is the geometric design. Based on the classification of the roadway, roadway needs to meet certain geometric features, and it needs to that actually influence in the overall alignment. So in a national highway you will have a milder curve, or expressway you will have a milder curve compared to the local highway. So that is one example. Economy, it depends on the cost, available money, and the maintenance cost in future. All these things is going to affect the or influence the alignment. Other special consideration, as I told you, the stability of the hill, requirement of adequate drainage if needed at certain location, the geometric standard of hill road. So if it is going through hill road, it has a different standard, it needs to meet that. And the resisting length, so the resisting length is for the vehicles, whether it has lot of resisting length, that is the tractive effort to carry the load, then you should actually reduce the gradient. So we'll be discussing this thing now when we get into the design aspect. Now I got again the same question which I probably answered. How much time does it take to do preliminary survey and how it is done? So I'm not yet there. So I'm again, as I told you earlier, I'm going to discuss that, and as you go through that process, we'll see what it entails or what it needs to do that. The necessity of I got another same question which I answered just before. Is there any empirical what are the main design consideration of rural and urban roads? This will again come. So some of the questions are being repeated, like how toll tax for expressway and national highway are divided among. Part of the discussion as we go through, and I'll take those questions at the end. Some are asking regarding the radius, so that once we get into the design we'll know more about it. Now there is another question about, is there any empirical relation between population and the design of highways? No, there is no empirical relation between that. However, the length of the highway maybe there is a in a planning stage there is a empirical relation with the population to find out what should be the density of the highway. So we are not getting into that much that either to that extent. So now coming to the surveys, basically the first survey of the process is the map study. So in this map study we get an idea about the overall possible routes of the road, and in the map study you will also find out what are the intermediate city there, and what is and it needs to be connected and so forth. Okay, so I got a relative question, which is what is resisting length and how it is calculated, what is the effect of the alignment. The resistive length is the traction force which is needed to carry the load, and the way it is considered is looking into the tractive force a vehicle can impart, and what is the load carrying capacity, and whether it is going to slow down at so this is more the mechanical behavior of that, and from there we look into what is the distance it can go at certain speed. If it is going to reduce the speed and it goes to very low speed, we need to reduce the gradient so that it can maintain the speed. So that is more about the. Now, does Lucknow Road Congress gives explanation for the alignment for a national highway? See, these road congress are for the planning purpose. They are not going to tell you about the alignment. These are going to say what is the density of the roadway in need per 100 square meter. What are the type of cities you need to provide connection. So whatever you are asking, this is coming from the design aspect. So when we look into the design, we need to, as I told you, the controlling factor. So this natural calamity and all these things could be one of the controlling factor. If in certain area, if you see natural calamity happens very often, then you don't want your alignment to pass through that area. So now coming back to the surveys, basically the map study, that is you are just looking into the map, and then it comes to the recognition. This is where you are going out in the field and looking into some basic idea about the feasibility of the route, and looking into the soil type, what are the different type of soil there are, whether you need cross drainage at certain locations, so you get a better idea, the flood level, so maximum flood level, and this answers one of the questions like the natural calamity. So if you look into the flood level is quite high, you need then once we, based on all this information, we decide the alignment, we move to the next preliminary survey. So in the preliminary survey, basically we need to collect data from the more additional data and detailed data, and here we should have data, enough data to estimate the earthwork. So if we know our alignment and if we can construction needed, so suppose your alignment is going through a rocky area, so it needs different kind of excavation and the different kind of construction. So that in the preliminary survey, those things will be revealed. Based on that, we need to finalize the best alignment. So before that, we might have 3 or 4 or 5 alignments, and we'll be finalizing that. And then once we finalize our alignment, we'll be looking into the detailed survey. We'll do the detailed survey and find out the exact quantity, exact impact, and the kind of construction needed, and all those step by step. And in the overall process, we need to prepare drawings and reports. So whenever we are preparing the drawings and the report, in the drawing we should have key map, index map, preliminary survey plan, detail plan, longitudinal section, detailed cross section, land acquisition plan, drawing of cross drainage, drawing of road intersections, land plan showing quarries, and all those. This comes as a package, and which will go to the construction, go for the construction. And the report contains all the detailed information right from the planning stage. What are the assumptions in those planning, why we made certain decisions. All these are properly documented in the report, and it goes in the design, what specification has been chosen for the design, what was the design speed, and all those details are reported in there. And then it will. So now let's look into the map. So here if you see, the key map is this one, and the key map is basic criteria is to find out what are the major cities, what are the major locations it is going to connect, and intermediate, what are the major location it may need to connect. So it doesn't give you the overall details like what could be other. Whereas the index map, it can contain the topography. So this is more in a city area, so the topography is quite plain, so we didn't provide the topography, but it shows the road network within the city, so that we know like how this the new highway can be connected. So the index map is little bit much more detailed than the key map, but the key map will tell you the locations. And then we go for the preliminary survey. So preliminary survey will, if we know our alignment, few alignments, and we will do some survey around that, what is there, what is the soil type, what are the difficulties are going to be there. So this is one of the survey map you can see for an intersection improvement, and they just go around this area to find out various alternatives, what are the improvement they need to do. And once we do the preliminary survey and we finalize our alignment, we come for the detailed plan. And once we do the detailed plan, this is how it is going to look for an alignment. And when we look into this, basically we have the width of the roadway, where the median is going to be, what is the right of way we need, and the carriageway, and if there is any structure, cross-drainage structure we need, that also we need to provide here. And if you look into the other details, it is provided. So this is the plan. So we told there are two parts, like horizontal alignment and vertical profile. The horizontal alignment is captured in the plan, and the vertical profile is captured in the profile. So the profile is also known as longitudinal section. So this is what you are looking at, like X and Z plane. So this is the roadway, what is the gradient of the road which is going, whether there is any vertical curve, and the gradient, we will be discussing this again more. It also shows the existing ground profile and the road profile. So from this, the earthwork can be estimated. So these also provide the details of. Once we look into, we also need to look into where is the low point, whether we need to provide cross-drainage structure and all those things. So the longitudinal profile, in an art, I mean, if you want to see side by side, this is how it looks like. On the top you'll see the plan, and here you'll see the profile. So the same area how it is represented in the vertical profile, and the same area how it is represented in the horizontal. Thing we need in this overall design process is the detailed cross section. So we know that profile, how it is being laid out, what are the different layers of the pavement, how it is sloped to run off the water, where the median is, how this median is going to be, whether we need any structure for soil retaining and all those things. These are provided in the cross section, and the changes are provided, like from which changes to which changes this type of cross section needs to be installed or constructed for which location. So this is the detailed again, this is part of the drawing. The land acquisition plan. So once we know the plan, the roadway and right of way, from there if we plot the properties. So each property, you can see any property which is being affected by the right of way, proposed right of way. P stands for proposed, ROW, right of way. So these properties needs to be acquired. So in order to acquire this is a land acquisition plan. This is being sent to the administration, and the administration this land, and once this land is procured, it goes for the construction. And before this, actually someone needs to go out, do the survey. So it depends on the project, how long it is going to take, all the details. It depends on the details available already existing, or it also depends on the how dense area is there. So there is no like one answer for that. So now it also, the plan or the design also consists of cross-drainage structure, whether it's a masonry structure or concrete structure, what is the retaining structure. So here you are seeing one of the cross-drainage structure, or sometimes these type of structures are needed for vehicle underpass or cattle underpass, or pedestrian underpass to connect the two sides of the roadway. So these type of structure details are there in the design. So, and it is an intersection, the intersection details, like what should be the curve at the corner, where how many lanes are going to come at the intersection, how we should cut the this thing, the median, so that it can facilitate the turning movement. So this particular drawing is for US the right hand side driving, so that is why you will see on the right hand side for all these things. So these are again part of the so once we know this intersection design and Then you also need to know the quarry plan. So if this is your alignment, what are the possible quarry locations, how you can procure the material, and how you can do that. This is provided in this. If you look into the overall project, then there are various different kind of projects. So one is the new construction, where you are completely going to design a new highway and you are going to connect construct a new highway. So this is part of the new construction, where you have to consider all the factors. Now sometimes it could be a reconstruction, and a reconstruction mainly a highway exists and you need to change certain portion of the highway because of the deficiency in geometry, so those involve major changes, and but mostly you'll be using the existing alignment. So that type of reconstruction can happen. Then the other type of improvement projects are resurfacing and restoration. So in the first two, this type of project, the design plays, or the design engineer plays a major role, because they need to say how this design needs to be done. Then comes the resurfacing and restoration, rehabilitation, and in this type of project, basically we need to look into how the project needs to be restored, and how whether we need to do the resurfacing of that. And in this process, if there is some minor deficiency, then other is the maintenance project. So if the deficiencies are there, again the design engineer comes into play and they look into that. The maintenance mostly is just a maintenance to keep the good road in a good condition, and hardly the design engineer plays a role in this unless there are some improvement needed. So these are the various. The next will be moving to the geometric design, and today we'll be discussing about the side distance. So if there is any question, now I'll move to the geometric design of road. Before we get into the geometric design, basically we need to see the overall process. So the road design, as I told you, it is of two components. One is the geometric, another is the pavement. So the geometry, you see the plan and profile. The pavement is the either a concrete or the bituminous pavement that you see. Now the pavement design again has two parts, mainly the flexible pavement and the rigid pavement. So these are the pavement design part, which is again not part of this course. Our concentration is here. So the geometric design, as I told you, first one is the alignment design, and within alignment there is a horizontal alignment and vertical profile. And to do this design, we need to consider the side distance. The side distances, the main side distances which we consider in this alignment design process are stopping side distance and overtaking side distance. Apart from this, there are other side distances which will go through as we process. If we look into the definition, basically the geometric design is concerned with the positioning of the physical elements of the roadway according to standard and constraints. And whenever we are talking about these physical elements, what are these physical elements which are visible to the driver or the road user? One is the horizontal alignment. They look into the horizontal alignment, whether there is a curve ahead, whether this is a tangent section, all those things. The vertical alignment, whether again this is a vertical curve or gradient, whether there is a gradient or not, that is the vertical alignment. Side distance, how far a road is visible from for a driver. So that is the side distance. So that length is actually part of the geometry. The cross section details. The cross section, whether there is one side there is a valley, one side there is a mountain, or both sides and there is a down slope, or whether it is in a plane. So that cross section details is important. Whether in a curve there is a super elevation. I'll come to this super elevation later. Super elevation is there or not. Another information is intersection. Whether there is an intersection, whether there is a right turn bay, or whether there is a free left turn or not. All these things part of the intersection and how the driver perceives. So these are part of the geometry. And whenever we are doing this design, as any other design, basically we look into this thing, like whether the design is cost effective and economical, and whether it is providing the maximum comfort and safety and provide efficiency in traffic operation, and whether it is minimizing the environmental impact. So these are the basic guidelines or basic things based on which the overall geometric design is there. As I move to as we are discussing, we are getting questions. One question is, what are the special design consideration of alignment required on ghat section? So let's get into in depth about the design, geometric design and all those things. Probably we'll see what are the special considerations we are looking into. Now the factors which affect the geometric design. One is the design speed. So the design speed, you are designing a facility, what is the speed of the vehicle which the vehicle can travel. So each facility is going to be designed for a different design. The topography, what is the terrain type and how the standard changes with the terrain. So this is where the ghat section comes. Like ghat section has a different terrain which is called it steep or mountainous terrain, and it has a different standard. And these standards are coming from the speed, from other aspects. As we go through, we see. Design vehicle characteristics. So design vehicle characteristics, you are designing a highway for the user. So the user in this case are the vehicles. So the vehicles in the sense, there are cars, trucks, other vehicles. Now trucks, whenever you look at multi-axle truck, then the regular truck. So each of these trucks has different operation, or they operate differently. So if you ask a multi-axle truck to make a turn, it will take a wider radius. So if we are designing a facility where vehicles are required to turn, and that facility is going to be used by a multi-axle truck, we need to design for that particular vehicle. So that becomes our design vehicle. Design vehicle characteristics. We need to look into those type of characteristics. If you are designing, if there is a gradient, and if we see that a vehicle needs to climb this ascending gradient, what is the speed it is maintaining? Whether it can maintain the design speed or the operating speed, and it can go without the vehicle or not. If not, we have to consider other design. So this is the design vehicle character. The human factors. These vehicles are driven by the human. How do they perceive the intersection? How they look into the gradient? How they look into the curve? What is the is there any confusion in there? So the human factor needs to be considered when they are seeing how well they are reacting. So these things comes into picture. Now the other factors are traffic. So if you're designing a highway where you have a lot of traffic, you need more lane. So the level of service and all those things, the traffic plays a major factor in there, and the quality of the road, and the environment factor. So how much air pollution is going to happen, noise pollution. If your highway is passing through a community, the new highway, and high-speed vehicles are going to go through, they are going to honk, they are going to, the road tire interaction is going to make noise. How this noise is propagating and affecting this community, whether it is going through some environmental area, how it is going to affect. So these things, and these are the factors. So if it is going through a community, you may need to probably provide a noise barrier and so forth. The economy, how much money you have to construct this highway. So that definitely plays a major role. How we are going to balance this, the money available and the standards you want. So definitely that is going to affect the geometry. The other aspects are aesthetic, road crossing, railway crossing. So I'll take the next question, which is, if the alignment of the road gets incorrect, then what will be the best feasible method to correct it? So first of all, if the alignment gets incorrect, it needs to go through the reconstruction, and that alignment needs to be modified according to the present standard and upgraded. So if it needs whatever the changes needed, it needs to be compared. And moving into the design speeds and the terrain, as I told you, like the terrain plays a major role, and the major role whenever we see the terrain, as we say, like plain, rolling, mountainous and steep. The ghat section, whenever we talk about, we are talking about steep section where the slope, cross country slope is more than 6%. Based on this, we will be deciding this. Again, the speed depends on the category of road or the classification of the road. We have various classification, national highway, state highway, and based on that, once we look into that, IRC provides this speed classification. So here you see the terrain type, plain, rolling, mountainous and steep, and here you find the expressway, national highway, state highway, and then based on that you choose the speed. Now here you have two speeds, one is the ruling speed, another is the minimum. So mostly a designer is going to try to design the speed based on the ruling speed. So based on the terrain type and the road category, they will try to do it. At certain small stretches where they cannot meet the ruling speed, or and it is going to be cost prohibitive to consider this ruling speed, meet the trilling speed, they will be considering the minimum speed. So minimum speed is 100. So you can imagine, means once the speed is reducing, your geometric details are going to change, and how it is going to change, that is the part of the thing. So I'll take the another question: why alignment is necessary for highway design? So alignment is necessary to find out, as I told you, the alignment lets you know that whether it is going to connect the intermediate city, whether it is going to avoid certain area, and whether it is going to fulfill your requirement. That is why the alignment is needed before you actually embark into the full-fledged design. And in the alignment itself also, you are actually doing some basic preliminary design. So this is why the alignment is needed. Another question I got is, does any additional care has to be taken into account while aligning roads in a hilly area? If yes, what? And the additional requirement feature needed in the hilly area is the slope or the valley side, if there is a stability of the slope. So this is coming from the geotechnical point of view, whether the slope on both sides of the roadway are quite stable and it can take. And the geometric design point of view, this is what you are looking at. You have to decide about the speed and the design vehicle which is going to go through. You want to put a hairpin bend, and you have a tractor trailer or this multi-axle truck which cannot go through this hairpin bend, and then it's wrong. I mean, you are not satisfying the design vehicle. So you need to look into the design vehicle. All these aspects are there. So there is nothing out of blue except the slope stability. Again, geotechnical investigation is needed, whether it is in a hilly terrain or any other road. One more thing which I told you about that resisting length or the resistance which is going to get from the. So the design speed also is governed by the Motor Vehicle Act imposed. So the Motor Vehicle Act also says that this could be the speed of a vehicle. So you will see many places that truck speed is 40, car speed is 60. So design, the Motor Vehicle Act imposed that trucks should not go more than 40 kmph at this road, and 60, the car should not go more than 60. So that is coming from the Motor Vehicle Act. And as I told you, this speed vehicle category wise regulation is there. Then in the urban setup, the speed limit is coming from this way. The arterial will have 80 kmph, sub-arterial will have 60, collector streets will have 50 kmph, and local street will have 30 kmph. So these are the speed. Based on that, we will be going into the design. So another question came up: does climate condition affect geometric design? We'll see. We have consideration regarding that. So vehicle characteristics. Now coming to the vehicle characteristics, as I told you, the design vehicle, we need to look into its width, length, height, axle load. So with that, we'll see whether our facility can serve all the design vehicle or not. So the requirement for this type of truck for the turning is different than a bus like this, and the car is going to be different. So whenever you are designing a cross section, you need to see who are the user, where they are being put up, how they are going to access the whole facility, and whether we are satisfying this. Now human characteristic, as I told you, the human characteristic is also there because the human is driving the vehicle. So in this figure, if you, as you say, if there is an object and or something and the vehicle needs to stop, so the vehicle needs to react to that, and whenever it is reacting, definitely there is a human characteristic, and the human characteristic part of it is, we call it PIEV, which is perception, intellection, emotion, and volition. We'll come to these details in a while. And after this, once the human characteristic comes into, then the mechanical characteristic comes into place, which is the brake reaction, which is the braking process. So within this reaction, actually there is a human reaction and the mechanical reaction, and then the actual physical process. With this, the vehicle is going to stop. So these are the very basic parameters through which the road is going to be designed. Now let's look into the next part, the side distance. So this is the side distance through the primary component through which the design is going to be governed. Because at most you want a vehicle to stop at whenever there is a danger, and whenever it is stopping, that is called the stopping side distance. Then the other type of side distance are intermediate side distance, overtaking side distance, headlight side distance, and safe side distance. So we'll go one by one. So let's look into the stopping process. So in the stopping process, what happens? a vehicle needs to stop when it sees some danger ahead, here some object, and the process involves like a driver sees that object, react to that, apply brake, and then the physical braking starts. And now there are certain specifications. As per the guideline, the vehicle, the height of the eye is at least 1.2 meter. So if you are at a higher height, you can see far off, but 1.2 meter is the minimum height through which you can see. And the distance through which you need to see is about 0.15 meter or 0.1 meter around. This is the object you need to see, and this is what is coming up, because if your object height is less than that, actually the vehicle can go over that. There is no issue. So this is now let's look into the process, how driver is going to react. So whenever someone is going to look into some object, or so they are seeing through their eyes. So the eye look into that object or hears something from side, based on they are going to react. So the information came to our eye and our ear, and it requires some time to send it to the brain. It's going to be a very, less fraction of a second, but it is still there. There is still some time, and this time when the information goes from our eye and ear to the brain is called the perception. Once it goes to our brain, we need to process that information to understand what is exactly happening, and that is called the intellection, and this will actually evaluate what is the situation. And once the intellection happens, then the driver gets into a mode of fear, or the mode of something like whether there will be some emotional action, and this will be, or there will be anger, there will be honking, something they have to do. So there is an emotion state. So this will again take some time, and this is what the emotion of PI is. And once the emotion is fully developed, then they are going to think of the action. Think of the action means, in this case, if they are stopping, they have to press the brake. That is their action. So that is the volition. And once they decided, now they are going to apply the brake. So when they apply the brake, there is again fraction of a second, or till you press the brake and the vehicle is going to react. So that is your brake reaction time. So altogether, this is your total reaction time. Then the brake gets engaged, the braking process starts. So before the brake gets engaged, that is your lag time. The vehicle is traveling at the same speed in that time. Then once the braking starts, it's going to reduce speed and come to a complete halt just near the object. So this is the total distance we are looking at. So and this total reaction time as per IRC for stopping is considered just, I'm repeating again, just for stopping it is 2.5 seconds. There are the reaction time for other divisions are different. It's 2.5 seconds. Now, before I move to the next slide, I got another question, which is, in some places of road, side of the road, it is written that accident prone area, there is a fault in geometric design or alignment of the structural design. It could be fault of the operation as well. Suppose there is an intersection and the side road are supposed to stop, the vehicle coming from the side road are supposed to stop, and whenever there is a gap, they are supposed to enter. So if people are not following that, they just enter the high speed road like that and get into accident. So there is no fault of the geometry, there is no fault of the alignment, it's the fault of the driver there. So in this case, we can have a secondary improvement on the alignment, which can actually help which can help to in this situation. One is that you will often see that they put a speed hump or the speed bump on the main road, which is again against the natural law. It should not be on the main road but on the side street, because the side street, if someone is coming from the side street, they have to first gauge what is happening in the bigger street, and then only they need to enter. So that is what it is. And again, it could be design fault as well. So this is one aspect is the traffic operation fault, another is the design fault. If there is a sharp curve which from the intersection, if you cannot see the main road, then of course that is a design fault. And alignment fault, if you want to say like whether to consider a bypass or whether the curve was quite sharp, then you may consider as a alignment fault to some extent. So it depends on that. Okay, so next, if we look into this now, moving back to side distance. So if the definition wise, it is the minimum distance available visible to the driver ahead of them, and this is required to stop the vehicle safely. And this side distance depends on the feature of the road ahead. What are the features? I'll come to that. Height of the eye, which is as I told you 1.2 meter we consider. If your height is more, definitely you are in a better shape, but at least it should be 1.2 meter high, so that vehicles are designed and looked into this factor. The height of the object, as I told you, 0.15 meter. So if the height is less than that, basically the vehicle can go over it without any issue. If you look into the stopping side distance, it will definitely depend on the total reaction time, because that is the lag time when the vehicle is traveling at the same speed. Then the speed of the vehicle, if a vehicle is at a higher speed, it will take lag time, lag distance is going to be more, and the braking distance is also going to be more, because it needs to come from that speed to the lower speed. Efficiency of the brake, so that is also needed. The friction resistance between the tire and the road, so that is also needed, because if the friction is less, it will take more distance. If the friction is more, it will take less distance. And the gradient of the road, the physical characteristic of the road, as I told you. So with all these factors, let's look into how we design it. The speed, we consider it as a design speed of the roadway. Braking efficiency, generally we consider it as 100%. Then the friction, we consider it as in a dry. This friction depends on the dry and wet condition. So IRC recommend it to be 0.35 to 4. Now this is again the climate condition prevails. So if you have a roadway where the climate mostly it's going to rain, you will rather design the consider the friction factor on the lower side. So this is how it has been taken care of. So now again coming to the stopping side distance, it is part one is the lag distance and the braking distance. There are two parts. So I am trying to answer the same question which is right now posted. So lag distance, as I explained you, it depends on the reaction time of the person who is driving as well as the reaction time of the braking system. That is when the vehicle is going to travel at the same speed whatever it was at that time, and then the brake is engaged and it starts decelerating. So this is the braking distance. So this is the overall stopping side distance. Now if you look into the overall, as I told you, the lag distance, so the vehicle was traveling at a certain speed, say 80 kmph or the design speed, 100 kmph, whatever the design speed is, and the lag time we considered it as IRC 2.5 seconds. So with that, this is the distance it is going to travel. In between this perception and all PIV thing happened, and the brake reaction time, that also happened, and now the brake is engaged after this distance. And once the brake is engaged, what is happening? The vehicle had a kinetic energy. That energy is going to be lost in the form of friction. So the kinetic energy, if you look into the equation, is half mv squared. V is again the design speed. So the mass can be represented as weight by g. So wv square by 2g. And the friction loss, the energy lost in friction is F is the friction factor, weight. So this will give you the energy lost here. If we equate these two, from this we will get the distance required to stop the vehicle due to the deceleration. So this distance is d2 equal to v square by 2gf, and again v is the design speed. So the total distance is this plus this. You have to just balance the units. In this case, if you are considering, v could be in meter per second, d is in meter. and friction, design coefficient of friction, as I told you, it is 0.35 to 4. It depends on the climatic condition. You can choose one. Gravitational acceleration 9.8 meter per second and so forth. Weight of the vehicle in Newton you can consider, but ultimately you don't need the weight. So overall, if you look into, so d1 plus d2, this is the overall you are getting. Now the situation can come like your roadway is on a gradient. So if you are going in an upward gradient or ascending gradient, or whether you are going to go in a descending gradient. Descending gradient will definitely require a longer distance, whereas the ascending gradient will require. So when someone is going in a that gradient factor needs to bring into this equation. So if you look into this equation, when the gradient is there, we consider this. If n is the gradient in percentage, so 0.01 is the times n is going to give you the gradient. Now, if you are going in the ascending gradient, your distance you require is less. So, if you require less distance, that means this part is going to be, the denominator is going to be more. So, in that case, it should be plus, the ascending gradient plus, descending gradient negative. So, if you put accordingly, your distance are going to be adjusted, and based on that you need to find out the distance, stopping side distance. Now, the other part we discussed was the braking efficiency. So the braking efficiency, in case if you have a braking efficiency which is not 100%, you need to accommodate that. So here is the factor which will take care of the friction along with the friction factor. So braking efficiency is directly coming out from the this friction factor. So if you go back to the previous slide, so the braking energy is dissipated through this friction. So that is why we are multiplying the friction braking efficiency with the friction factor, and this is how we take care of the. Once we know this, then we can find out the stopping side distance. And I think in next 5 minutes I can conclude. So the stopping side distance that we talked about in the straight section, we may get into a situation like this, or we have a highway which is on curve, and a vehicle, whenever it is measuring the distance, it is along finding from this curve, but their eyesight is always straight. So if there is a obstruction here, you cannot see the object. So your object needs, this obstruction should be free from your eyesight, and you should be estimating this distance. And how to do that will come at a later stage, but the offset distance calculation. But when we are talking about the horizontal alignment design, but this is how we consider it. Now the other part is also happens in the vertical alignment when there is a curve. So when there is a curve like this, so your eyesight is actually through this state, and you need to see this object. So again, this height of the object plays a major role, and this is how you need to see what is the distance it's going to cover. The next thing, I mean, here are few examples. In this image you can see the vertical, due to this vertical alignment you cannot see the other side, and this is why they have put up this board which says no side distance. Here you can see on the horizontal, due to this curvature, you cannot see the other side, and same thing for this curve. So as long as if you meet the side distance from here to here, then you are safe. If it doesn't meet, you need to lower the speed or improve the geometry. So here is, I mean, in this 3 slide you will see how the vehicle disappears, and this will give you, so the vehicle went to the other side of the curve and now it disappears. So see how the process, I mean, how this vehicle is disappearing. That will give you an essence of how the side distance is affecting. The other part of the side distance is like the undercrossing. So if there is a railway track or some other highways and you are coming, so your side distance may be blocked by this structure. So this also needs to be looked into, whether there is any obstruction to that or not. So accordingly things needs to be designed. And so what do we do in this case? Like if you have an obstructed site, and so there are 2 things you can do. Either you can put up this type of sign to warn the driver, and also put up a sign of the reduced speed. The second thing, which is the good thing to do, is to correct this geometry and improve this geometry. Once you do that, then you don't need to put this sign. But for temporary purpose, the moment you find out the there is a side distance deficiency, and the driver needs to be informed properly, and the safe speed needs to be indicated. Now the second part is the overtaking side distance. So the overtaking side distance we need to provide in a highway, like so that the slow moving vehicle can be passed by the high speed or the fast moving vehicle. And whenever we are doing this, we need to make sure that the complete operation takes place without any hazard. Means in a highway, a vehicle can come from the opposite direction. It should not get into the head-on collision in this state. And so the overtaking side distance depends on the speed of the vehicle which is being overtaken, and the vehicle which is coming from the other direction. And the space you need to mention between the overtaken and the overtaking vehicle while it is doing that, skill and reaction of the driver, and the rate of acceleration of overtaking vehicle, gradient of the vehicle. With this, if you look into the overall process, in this figure you can see the green vehicle is supposed to overtake the red vehicle. So the red and blue vehicle is coming from the opposite direction. Now the green vehicle is forced to follow the red vehicle until it finds the enough distance to overtake. So when it is forced to follow the red vehicle, it is actually traveling at the lower speed of this red vehicle, the overtaken vehicle speed. So it will, and once it finds that there is a gap, means it again that PIV reaction time comes, it has to understand and react to that and then start the process. So this is what the distance D1 says, is the distance traveled by overtaking vehicle following the red vehicle during that reaction time. Once it decides to make overtake, it actually accelerates, go past, and again maintains the minimum safe distance and come back. And this is the distance traveled by the overtaking vehicle during overtaking operation. So D2 is that distance. Now once it completes that process, you also need to ensure that the vehicle which is coming from this direction, the opposite direction, is also traveling certain distance. So this distance is D3. So D3 means then it will actually be on the safe side. It is not going to collide. So the blue vehicle. So this becomes your overall minimum stopping side distance. And based on that, you have to provide the distance or the facility for the overtaking. So as we said, overtaking side distance is D1 plus D2 plus D3. If you look into the other design code like ASTO, which is American code, they have one more factor D4, which also consider the safety factor within this blue car and the green car. So between D3, they want to see that there is certain distance between these two cars. So that is the distance they include. But here in our IRC, we only consider D1, D2 and D3. So D1 is very simple, straightforward. It is the reaction time when the green vehicle is deciding to overtake, and at that time it is following the red vehicle at a reduced speed. VB times the T reaction time and the velocity of the overtaken, it is traveling at the overtaken speed. So T is the reaction time. In this case, as I told you, this is a different reaction time, 2 seconds. Earlier for the stopping it was 2.5 seconds, now it is 2 seconds. So, and this is VB is the the speed of the slow moving vehicle. In case the slow moving vehicle is not known, you can safely consider it as 16 kmph lesser than the design speed. So you know D1. The D2 part is the overall overtaking process. Now in the overtaking process, before overtaking it was maintaining certain distance, safe distance, spacing between the vehicle, and after the overtaking process is complete, again it is going to maintain that space. So it is 2 times S. So this is coming from that space. And then it also needs to accelerate and come back. So this distance is calculated. There is an empirical formula for this. S is 0.7 times VB plus 6. So this is the empirical formula to find out the spacing. And based on this spacing and the total acceleration rate, the total time to complete this is capital T. And capital T is estimated by this formula, root over 4S by A. And so we know T, we know S from these two formula, and then definitely we can calculate D2. So once we calculate D2, we know then we need to calculate D3. D3 is nothing but the design speed of the vehicle which is coming from the opposite side. Please remember, the opposite side vehicle don't need to slow down, because they are not following any vehicle, they are just coming on their design speed. So they are coming at that design speed V, and the time is the total this time, the overall operation, the overtaking operation. So this time times design speed will give you the D3. Together that is going to giving you the overtaking speed, distance. Now how to consider this in the zone? So we need to, if we cannot provide overtaking side distance everywhere, we need to provide certain zones where overtaking could be allowed. Zone is as per IRC, we say it should be minimum of 3 times of the overtaking side distance and maximum of over 5 times of the overtaking side distance. And the way it is referred is that we should provide a sign here at overtaking side distance, and that overtaking side distance zone is coming up, and then it comes up before it ends with a distance from overtaking side distance. Another sign is provided here which says that the overtaking side zone ends here. That way it completes. So this is the overtaking zone. Now the intersection is quite simple, straightforward, but it is based on the stopping side distance. So at an intersection, a vehicle coming from two different roads needs to see each other, and in worst condition they should be able to stop before colliding. So both should have enough distance to stop. So when both are traveling at a same same speed, design speed, they should have enough time to react and stop. So you have to consider stopping side distance based on the design speed of this road, and the stopping side distance from design speed of this road, and from there you connect this, and your obstruction should not have any obstruction at this from this triangle. So this is the intersection triangle for the side distance. So this is how you do the intersection side distance. Next thing is the intermediate side distance. So intermediate side distance, generally we say it's the 2 times of the stopping side distance. Actually what happens, we have a road category where we call it intermediate roadway, which is 5.5 meter length, width, and we expect vehicles can come from both directions, and when they come close to each other they will just slow down and manage to pass each other by going little bit on the shoulder if required, and then they can go back to their original speed. Now in this process, basically you expected to see the vehicle which is coming from the opposite direction slow down and adjust your position, adjust the vehicle position in such a way that you can slowly, safely pass each other. So in this case, the worst condition is going to both vehicle needs to stop. So if the both vehicle needs to stop, means you need to provide the stopping distance. So only difference you can consider here is that the object which is on the other side is also 1.2 meter high. So both cases is 1.2 meter. In the stopping side distance, we consider it the object height as a 0.15 meter. Now what would be the difference if we consider the object height as 1.2 meter? We don't have a guideline for that one. So that is why the IRC say that you just consider the 2 times of the stopping side distance. So the highways which are median divided, means where you don't expect traffic from the opposite side, you don't need to provide intermediate side distance. But if there are no median and you expect traffic from the opposite direction, then you need to provide the intermediate side distance instead of stopping side distance. And the headlight side distance, this happens in the valley. So in the night time when the vehicle is traveling, they are actually restricted by the headlight, how far the headlight is going and how far it is visible. So the headlight, as we know, light travels in a straight line. So based on that we can see how far it can go. So based on that we can find out what is the side distance. So how to calculate that, we'll discuss that later. So with that we concluded our side distance and today's lecture. So thanks to all of you and see you tomorrow. If you have any question, what you can do is like you can email me, you can see the email ID, you can email me, I'll try to respond, come with those answers tomorrow, and tomorrow we are going to discuss about the horizontal alignment. Thank you.